In our previous lecture, we have studied about one computing paradigm, that is client server model. Client server model. So, in this video, we are going to talk about few more computing paradigms. So, at every stage of the growth of the internet and the IT information industry, lot of computing paradigms have been proposed. Some of them have been evolution of client server, like drawbacks of client server were solved in some other model like peer-to-peer. There were some drawbacks in peer-to-peer which were solved in cluster computing. So, like this, some computing paradigms evolved one upon the other, and some computing paradigms were emerged only for a specific task. Like when we talk about edge computing, it was created or evolved only for IoT related tasks. So, all those come under distributed computing, because somewhere or the other, directly or indirectly, they follow the principles of distributed computing. What is the principle? The core principle: when you are solving a bigger problem, you divide that problem into smaller tasks, give each small problem to a single computer, let them solve, let the output can be combined together, right? So, that is the idea behind distributed computing. So, let us talk about peer-to-peer model. What is this? So, we will understand these models with a simple small example, okay, a small story or a small problem, I would say. How the city of data prepared for the grand festival, right? The city of Datapolis was preparing for a big annual event, the Global Knowledge Festival. Okay, so millions of visitors were expected. The city needed massive computing power to manage the tickets for the people who are attending, the security, the traffic, food delivery, live streaming, analytics, lot of stuff they have to do, because they are organizing a grand festival, Global Knowledge Festival. Okay, so what is this peer-to-peer computing? We understood in client server that there will be only a single server and a single client or multiple clients, but the whole code is deployed or presented in a single server. Client have to request, only then server will respond. Okay, so in peer-to-peer model, the task or the analogy to understand is neighbors helping neighbors. Okay, it means the city mayor initially asked citizens to help each other directly, because it's a very huge task. You have to organize a very big technical event. So, a small city or a small village or a small town, let's say, that cannot handle it by itself. A small set of organizing team cannot do that. We need to take help of all the citizens. So, how does this peer-to-peer works? See, each one helps the other directly. Okay, each house stored some information and shared it with the nearby houses. If someone needed a document, they asked their neighbors. If a neighbor had it, they shared directly. No central authority in the peer-to-peer model. Okay, so no central server. Every node is both client and server. Peer-to-peer means like this. They are connected like this. They are connected like this. Or let's say I have another one here. I have another one here, and this is connected like this. So, no one is a single client or a server. This machine, this M2 could be a client when this is requesting, and sometimes M2 becomes a server when M1 is requesting. M2 acts as a server, and M2 to respond to this request R1. M1 is sending request to M2. Okay, R1 is the request number. So, M2 is acting as a server and M1 is acting as a client. But for M2 to respond to R1, it need one more information. So, it is again requesting M3. In this case, what happened? This M2 became client now and M3 became server, right? So, at any point of time, a particular node, a particular system could be a client or could be a server. It can act both the roles, right? So, we use this technique in blockchain networks. Okay, technically, let us understand what is peer-to-peer model. See here, this diagram, if you observe, all are connected through internet. See, they are all connected to each other, peer-to-peer, right? Peer-to-peer model introduces a symmetric architecture in which all the components called peers play the same role and both of them have the capability or the capacity to act as a client or a server. Right? See, each peer acts as a server when it processes requests from other peers, and it acts as a client when it issues the request to other peers. So both roles they play. That is peer-to-peer model. There is no central server. So data is being shared among all of them. Everyone has the capacity. It means the program which you are designing, the application which you are designing is distributed among all the systems. That is peer-to-peer model. So advantages, there is no single point of failure like client and server architecture. It is highly scalable because adding new thing is easy. Resource sharing is done. Why? All are connected to each other. So resource is being shared. Load is also distributed. Decentralization, there is no central server, there is no central computer or machine which is taking care of everything. Disadvantages, security. Why? Because since everybody is connected to each other, one system might be a corrupt system. It can cause lot of security issues to all the other systems. Right? Availability issues, complex management. Why complex management? Lot of peers are increasing, then it will be difficult to manage. Right? And if you want to update something, see what is difficult update? In a program P is installed in all these peers. Anybody can give the response whenever I request it. Okay, but if there is some update to be done, let's say I want to add a new patch, I want to do some patch work, or I want to add some update program, I want to change something, then I have to change in all the systems because there is no central server. In client server what happened? Only in server if I change it is done. But here in all the machines we have to manually update if I want to make a change. Right? Same way integrity and trust comes because we cannot trust on any of the systems. Anyone can be a problematic system. So in peer-to-peer, all the systems are connected to each other based on the situation. Sometimes they act as client and sometimes as server. This is about peer-to-peer model. The next one is cluster computing. Okay, for the same requirement, data police, right? The city, their data police wants to organize the grand festival. For the same thing, right? The city built a central operation center. See, because everybody is talking in peer-to-peer, they were talking to each other, but there was no proper communication was there. Nobody, the mayor or the city head is not knowing what is happening, how the function is happening. For that what they have done, they have built a central operation center. One main office they have constructed, which contains lot of thousands of identical machines connected by high speed. Okay, they are connected to each other with the high speed network. Now all machines work together as if they are one powerful computer cluster. They are forming a group, and all the machines are located in the same building. Right? For user, it is looking like a single machine. Okay, so how does this works? One problem split into many parts, process it simultaneously at a time. Right? But the problem is tightly coupled machines. Machines are tightly coupled to each other. They are dependent on each other, and they act as a single system, and high speed local network is there between the systems. Okay, simple example, HPC cluster, high performance computing cluster. We do it like that. Since one system I cannot, this configuration of one system cannot help me in solving a problem, we form a cluster. Okay. So in technical terms, a cluster is a group of independent computers that work together to perform a given task. The basic definition of distributed computing is same as this. Right? Cluster computing is defined as a type of computing that consists of two or more independent computers referred to as nodes that work together to execute tasks as a single machine. Okay. The goal is to improve the performance, scalability and simplicity of the system. Like this, there will be a root node and there will be some slave nodes. They can connect to each other, they can talk to each other and solve the problem. But for the user, they see only one system, root machine. Okay. So Hadoop framework is one best example which follows this cluster computing, because in Hadoop programming we create clusters. So when you study the course Big Data Analytics, you will be talking more about Hadoop and cluster computing there. Simple. What is cluster computing? Connect all together and make a single large machine. Next is grid computing. Grid, so we know basically grid computing means something like this. Mesh, grid we say, right? What is this? So, the same example what we are talking about, right? Here, the borrowing power from other cities, right? Soon the city realized even the cluster was not enough. So, data police partnered with other cities worldwide. They sent parts of their computation to universities, labs and data centers. They said to process, we don't have enough space, we don't have enough computing power. So, they have sent the data to all the other cities and other countries, taking their help to solve the problem, right? Each city used its own hardware but followed common protocols. So, they have solved the problem. Everyone have followed the same protocols, right? I think the best example is this SETI. This is there even in NIT Trichy. Okay, so SETI was also established for all universities. I will give an example to you. So, NIT Trichy, okay, it has one problem. It requires lot of computation power. There are other NITs in India, NITW, NIT Karnataka, Surathkal, NIT Calicut, let's say we have these in South India. Okay, so what they can do, this NIT Trichy, whatever problem they have, they will be sharing it, to solve that, they will be dividing that problem into subtasks and giving that problem to other NITs to help in solving. Okay, so this is what simple idea, even this is practically implemented. This is about grid computing. It says borrow from other people and get the work done, right? So, it is geographically distributed, loosely coupled because the data is distributed among different cities, and resource sharing across organizations. Across different NITs, the resource is being shared. So, in technical terms, grid computing is a type of computing where it constitutes a network of computers that work together to perform tasks that may be difficult for a single machine to handle. I cannot do in a single machine, right? All computers on the network work under same umbrella and are termed as virtual supercomputer. The main computer from NIT Trichy looks same only, but in the back end the resources are utilized from different organizations. Okay, so the task they work on is of either high computing power or consist of large data sets. So, the goal of grid computing is to solve more high computational problems in less time. See, users, grid servers. So, user can see only this part, grid server. Backend, this grid clients could be many. They are from different organizations. So, in this example, borrowing from others, okay, sharing resources across the organizations. This is about grid computing. Then comes utility computing. Utility computing is the core idea behind the today's current cloud computing. What is that utility computing about? Paying only for what you use. Today's cloud computing uses this. Okay, what is this? So, in the same data police example, the Grand Festival example, instead of building cluster infrastructure or building an office, the cities started renting computing power like electricity. Okay, so they have, let's say they have huge infrastructure. What they are doing now, they are renting the computation power, and they paid only for the amount of computation used during the festival and stopped paying afterward, right? So, instead of like cluster computing, I am building one office, right? This is not sufficient. So, I may go for grid also, or else what can be do? The other option is utility. What is that utility? You take somebody else's resources, rent them for 1 week and pay for that 1 week. That's it. After that, you will not have any resources. Just pay them for 1 week because you want to use it. Okay. So, they paid only for the amount of computation used during the festival. So, pay per use model, metered resources means how much you are using. The meter is there on that particular service. No upfront investment, nothing need to be invested. You first utilize the service, later you pay the rent. This is the core idea behind today's cloud services. Okay, utility services. So, it is defined as a type of computing where the service provider provides the needed resources and services to the customer and charges them depending on the usage. Whatever service you need, we will provide it, but we will charge it later based upon the resources requirement and demand. Okay, it involves renting of resources like hardware, software, etc. depending on the demand. The main goal is to increase the usage of resources and be more cost efficient, right? So we can take advantage of the other people's resources, and we are paying money. We are not for free, we are paying money to them, right? So this is about utility computing. Sorry. So the cloud computing. Okay. Now, same data police, that grand festival event, what they are doing now, they are moving everything into the cloud platform. What is advantage? Servers can be scaled automatically when the crowd increases, data can be backed up automatically, services can be available globally and 24/7, right? So that is what cloud computing, on-demand self-service, elastic scaling and global access. From anywhere in the world you can access that service. Now, students or the participants who are coming for the grand festival, they need not to come and register here, they can do it from anywhere. Okay, so these kind of benefits we have. The examples are AWS, Azure or Google Cloud, right? So I think this is not required to discuss. We have already seen what is cloud computing. It's a type of computing where it is the delivery of on-demand computing services over the internet on pay-as-you-go basis. Okay, so we have a lot of cloud infrastructure over the internet. We can application, services, storage, everything can be accessed. The next is edge computing, right? So what is this edge computing? Now, when generally I will talk about IoT here. IoT is the best example. We have IoT sensors. We have IoT sensors at field locations. At field locations means it could be in agriculture land, it could be in a traffic signal, it could be in a train, or it could be in some AC or refrigerator at your home. We have a lot of sensors there, right? All that sensor data is being loaded into the cloud or some database through internet. The IoT data is the data which is continuously being generated is loaded into either cloud or some database in the local machine, right? After bringing here into my system, I am then processing it. Processing means I am running some algorithm, I am calculating some price, rent for that, or some task I am doing, some processing I am doing, computation processing I am doing, and then I am giving response back to the same IoT device. Let's say this IoT sensor was in some fridge. Okay, after certain time I have to stop its power, I have to stop that refrigerator. So that action I am taking out. How I am taking? Based on the input data received from different sensors, loaded into the cloud or database. After processing, I am giving the response. It's a time taking process. You have to bring the data to the cloud, store it nicely, do all that, take care of the data, then do processing and then give response. It is headache. What is edge computing? Edge computing says you do small computations at the data generation source itself. At the IoT devices itself where the data is generated, there only you make small computing facility. Solve that problem there itself, don't bring it to the cloud. That is about edge computing. Okay, processing happens close to the data source, low latency and saves the internet bandwidth, right? So edge computing is a type of computing that is focused on decreasing the long distance communication between the client and the server, because IoT device is it somewhere and the server is client is somewhere, server is located somewhere. So means it is in cloud. Let's say data from IoT device is loaded into the client, into the cloud. There I am processing it and giving response. It is headache. Instead, near the edge device, near the data generation source generating content device, you place a small computation facility. Let that data, IoT data, come to that facility. Then and there you do some run some algorithm, generate the response and give it back to the immediately to the device. Need not load into cloud. Okay, so this is done by running only a fewer process in the cloud and moving the remaining process onto user's computer, that is IoT device or edge device or some server. Okay, the goal of edge computing is to bring computation to the network's edge, which in turn builds less gap and results in better and closer interaction. See, cloud, this is the edge device. From this edge device, I am putting in the I am doing processing here instead of loading into the cloud. In between only I can do, or near to the edge device I can do the computation. That is about edge computing. Okay, and the final one is the fog computing. What is this fog computing? So same problem. See, data is there, cloud is there here. Here is the data generation source. Data source I will say. Data is generated here and cloud is here. You are bringing data here and doing the processing. Right? This could be challenging. It is okay, it will come fast only. But instead of that, why don't you make a fog there? You know about fog. See, clouds are on top, fog is in between. Right? Sorry. So fog is in between. Okay. So it acts as an intermediate layer between edge and cloud. This is edge. Instead of taking everything to the cloud, create a small data center here. Let me call it as fog. Let the computation happen here, and some request can go to cloud, some can come to fog. So cloud has unlimited storage, unlimited computation power. Fog has a limited cloud. We call it as mini cloud. Fog is a mini cloud. Bigger problems can be sent to cloud, smaller one can be done at the fog itself. Okay, so this is about fog computing, right? So between the edge devices and the cloud, the city placed regional fog nodes, mini data centers in each district. These fog nodes aggregated local data and coordinated with the cloud. So aggregation, doing small tasks were done at the fog. Then it was sent to the cloud so that job is easy in the cloud. Okay, local aggregation and analytics, reduced latency compared to the cloud. Right? So fogging, it's a type of computing that acts as computational structure between the cloud and the data producing devices. It is also called as fogging. Like this, between the cloud and the IoT devices, there is fog. So some processing can be done in the fog itself instead of going to the cloud. Or before sending to cloud, some processing can be done at fog, and then the nicely framed data can be sent to the cloud. That is the idea behind this fog computing. So these are different distributed computing paradigms. Lot of new things are coming, yet these are some common and very popular computing paradigms. One paradigm which is very popular or trending now is serverless computing, but it doesn't falls exactly under distributed computing. It's another variant of cloud computing. So indirectly it is a distributed computing paradigm, serverless computing, which we will be studying in coming topics. Okay, thank you.